Welcome to the deep dive, where we cut through the noise and get straight to the knowledge you need. We all want to feel, well-informed to grasp complex topics quickly, but honestly, who has the time to wade through piles of dense technical stuff?
Exactly. And that's why we're here.
Today, we're diving deep into something that might sound really specific, but it's absolutely critical for anyone working in or even just near industrial environments. Arc welding safety.
Yeah, it's a field that's, well, it's way more complex than just the sparks and the bright light that you see first glance.
Right.
So our mission today is to dig into these comprehensive safety guidelines and presentations we've gathered. We want to pull out the really important insights, maybe some surprising facts, and just the vital knowledge about arc welding safety.
Make it accessible for you, basically. Whether you're the one doing the welding, overseeing it, or maybe you're just curious about those sort of hidden industrial hazards.
Precisely.
All right, so we've set the stage for our deep dive into arc welding safety. Now, as we start unpacking this, the first, maybe most fundamental thing that jumps out from the sources is this. Safety in welding isn't just about protecting yourself, it's a shared responsibility, a big one.
Absolutely. It impacts everyone nearby. And a really crucial player in making sure everything's safe, kind of the human firewall, if you like,
right,
is the visual or welding inspector.
Okay.
Their role is incredibly important. They're doing safety audits on equipment, implementing risk assessments, dealing with permit to work requirements, and generally just monitoring operations to make sure they're safe.
So they're the ones connecting the rules to the reality on the ground.
Exactly. And the insight here isn't just, there's lots of paperwork. It's that arc welding safety is built on this robust living framework. It's a constant interplay between government laws like the Health and Safety at Work Act, then you've got health and safety executive documents like COHH regulations, and even specific site instructions, permits, risk assessments, plus local authority rules. It's multi-layered, so if something does go wrong, it's usually not because the guidance wasn't there. It's often a breakdown in, awareness or maybe just execution.
That makes sense. So the inspector is that key interpreter on the spot. But with all those different documents and rules, where do the practical challenges usually pop up? Is there a common gap between the guidance and what actually happens?
A lot of it comes down to vigilance, honestly. The information's there, the rules are pretty clear, but maybe the sheer number of tasks or just a moment of thinking, it'll be fine this once, complacency can creep in. That's why that living framework idea is so key. It needs constant review, auditing, not just setting it up once and forgetting it.
Okay, vigilance. Got it. And speaking of layers, our sources point to 4 main areas of arc welding safety that always need attention. What are those?
Yeah, the 4 big ones are, first, electric shock, second, heat and light, third, fumes and gases, and fourth, noise.
Right. 4 distinct categories.
And we should probably tackle each one because they all have their own unique dangers and the ways to safeguard against them.
Okay, let's do it. Start with electric shock. Sounds like the most immediate threat.
It is. It's one of the most serious right off the bat. Contact with electrically live metal parts can cause severe injury, even death. And it's not just the shock itself, but also, falls from the involuntary muscle reaction.
Oh, right. The reaction can cause another accident.
Exactly.
So when we talk about electric shock, is it all the same level of risk? Or are there different types depending on the voltage or where you touch?
That's a good question. You're right. It's not one size fits all. The sources break it down into 2 main types. First, there's primary voltage shock. That's the really dangerous one. Talking 230 to 460 volts.
Wow, okay.
Extremely hazardous. It happens if you, say, touch a live wire inside the welding equipment while you're also touching something earthed, like the machine's casing. RCDs, residual circuit devices, are absolutely vital protection here.
RCDs, got it. And the second type?
That's secondary voltage shock. Usually lower voltage, maybe 60 to 90 volts typically. This happens if you touch part of the actual electrode circuit, maybe a frayed cable, something like that, while you're also touching both sides of that circuit, like the electrode and the workpiece or the earth connection.
So still dangerous, even though it's lower voltage?
Oh, definitely. Most gear won't go over 100 volts open circuit voltage, the OCV, but even 60 to 90 volts can be very serious. That's why there are low voltage safety devices built into the welding circuit itself to try and minimize that risk.
It sounds like even that secondary shock, if it makes you jump or fall, that could be the real danger, the secondary injury.
You're hitting on a crucial point. Those indirect consequences, falling off a platform, hitting your head on equipment, they can absolutely be as bad or worse than the shock. Safety planning has to consider both.
Direct and indirect. Makes sense.
And whether it's a big jolt from the primary or a significant one from the secondary, the risk is real. And it all fundamentally comes down to correct wiring.
Okay, wiring. What does correct look like?
Well, a properly set up circuit needs three essential leads. First, the welding lead that runs from the power source out to the electrode holder or the torch, the bit you hold.
Right.
Second, the welding return lead. That completes the circuit, going from the workpiece back to the power source.
Okay.
And third, the earth lead. This connects the workpiece to a proper earth point. And crucially, the power source itself must also be properly earthed.
3 leads: welding, return, and earth.
And here's a critical detail. All 3 of those leads have to be beefy enough, they need to be rated to carry the highest welding current you're going to use.
That capacity thing, that brings up something called the duty cycle, doesn't it? I saw that mentioned. What's that about?
Yes, duty cycle. It's basically a measure of how much work a welding machine can do continuously without overheating. It's based on a ratio: welding time versus total time.
How's it calculated?
It's usually expressed as a percentage. You take the welding time, divide it by the total time, and multiply by 100. And the standard total time base used in the sources is 10 minutes.
Okay, 10 minutes. So give me an example.
Sure. Let's say a power source is rated at 350 amps at a 60% duty cycle. That means it can safely deliver 350 amps for 6 minutes.
60% of 10 minutes.
Exactly. 6 minutes on, then it needs 4 minutes off to cool down within that 10-minute cycle.
And ignoring that isn't just about the machine lasting longer, is it?
Not at all. The crucial point here, linking back to safety, is that pushing a machine past its duty cycle doesn't just mean it gets hot. It can cause the whole system to become unstable.
And instability means higher shock risk.
Significantly higher risk of electric shock, potentially fatal. It's a direct safety issue, not just maintenance.
Wow. Okay, so duty cycle is critical for shock prevention.
Absolutely. And it also reinforces why you need to check your gear regularly. Connections need to be tight, clean. Cable insulation has to be in good shape. I mean, I've seen situations where insulation was cracked or worn thin.
Easy to overlook, I guess.
Especially if you're in a rush.
Yeah.
But it's a disaster waiting to happen.
Yeah, that human element again. Complacency. What's the biggest hurdle in getting people to do those checks consistently?
It's often that just this one-time thinking, people know the rules, but maybe they're under pressure, job needs doing quickly. Might skip a quick look over. That's why training isn't a one-off. It needs constant reinforcement.
Makes sense.
And speaking of current going where it shouldn't, there's another hazard called current diversion.
What's that?
That's when the welding current finds an easier path back to the source, but not through the proper return lead. It might go through, say, a crane hook, a wire rope, maybe even the bearings in the crane.
Seriously, through the crane?
Oh, yeah. I actually saw a case once where a crane's electronic control system started acting up really erratically. It took ages to figure out. Turned out stray welding current had been flowing through its wiring, slowly degrading it.
Wow. That's a hidden danger.
Totally hidden. And potentially very expensive, not to mention dangerous if the crane malfunctions. A simple, correctly placed earth lead on the workpiece could have prevented all of it. Using that dedicated welding return lead directly back to the source, plus the separate earth lead, those are key safeguards against this.
Simple steps, huge consequences if missed.
They really are. But welding isn't just about electrical risk. All that energy turns into intense heat and light. And that brings us neatly to our second big hazard category.
Right, heat and light. So heat obviously means fire risk and burns.
Exactly. The arc throws off sparks, sometimes quite far, and they can easily ignite flammable stuff, nearby wood, rags, solvents, you name it.
So rule number 1 is clear the area.
Absolutely. Get all combustible materials well away. And you need to know where the fire extinguishers are, and crucially, what type to use for different kinds of fires, electrical material, etc.
Good point. And I saw a note about never leaving flames unattended.
Critical. Never walk away from a welding job, even for a minute, if there's any risk of smoldering. And always have extinguishers right there if there's any combustible material around you can't move.
Okay. And then there are burns from the sparks themselves.
Yeah, direct burns. Sparks landing on skin, even through thin clothing, can cause nasty burns. That's why proper PPE is non-negotiable. Welding gloves, flame retardant coveralls, leather aprons, or jackets sometimes. They're essential.
It's amazing how quickly a small spark can burn.
It really is. Sometimes you don't even feel it right away if you're focused, and later you find this painful burn.
Right. Now let's shift to the light part of heat and light, the radiation. This sounds complex.
It is a bit. The welding arc gives off radiation across 3 main ranges. Infrared, which is heat, visible light, what we see, and ultraviolet, or UV, radiation. And each one has its own potential for harm.
Let's start with UV. What does that do?
Okay, UV. All arc processes generated. Too much exposure causes skin inflammation, redness, irritation. It can lead to severe burns, blistering, skin flaking off. And over the long term, with intense repeated exposure, it can increase the risk of skin cancers.
Is it like sunburn?
Interestingly, no. The sources point out it doesn't cause that tanning or browning effect. It's more about reddening and irritation from changes in the blood vessels near the skin surface.
But the biggest UV risk for welders and inspectors too is arc eye or flash, right? Tell us about that.
Yes, arc eye. It's basically an inflammation of the cornea, the clear front part of the eye, and the conjunctiva, the membrane covering the white part. The UV radiation damages the very outermost layer of cells on the cornea.
Ouch.
Yeah. When those cells die, they expose the supersensitive nerve endings underneath. That causes intense pain. The classic description is feeling like you have sand or grit in your eye, and it gets way worse in bright light.
And the really tricky part is that it doesn't happen straight away.
Exactly. That's what makes it so insidious. Symptoms often kick in several hours after you're exposed, maybe even hours after you finished working. You might not have even noticed the exposure at the time.
I've heard stories like that, welders waking up middle of the night in agony.
It happens. It's a brutal reminder of how sneaky UV is. The pain usually lasts about 12 to 24 hours, and thankfully it's normally temporary. But prolonged, frequent exposures, in rare cases, they can cause permanent damage.
What's the treatment?
And prevention.
Treatment is usually rest, keeping the eyes closed, preferably in a dark room. Soothing anesthetic eye drops can give immediate relief, but they really should only be given by a qualified person like a nurse or doctor. But prevention is definitely the way to go. Just wearing standard safety glasses with side shields offers significant protection against stray flashes.
Okay, simple glasses make a big difference. What about the visible light? The visible light from the arc is incredibly intense, especially the blue wavelengths. It can definitely dazzle you, making it hard to see for a bit. In really extreme cases, it could potentially damage the retina's nerve network. Usually, though, your natural blink reflex helps, and the dazzling effect is temporary.
And the last one was infrared, IR.
Right, infrared. You feel that as heat. The main eye hazard from IR is actually long-term. Years and years of exposure can cause a gradual clouding of the eye's lens. It's irreversible, called cataracts.
Cataracts from welding?
Potentially, yes, over a long career with insufficient protection. Fortunately, the sources say the IR intensity from typical welding arcs usually only poses a risk quite close to the arc. Plus, the intense heat you feel on your skin around your eyes usually makes you flinch or move away, which naturally limits how much IR your eyes actually get.
So how do you protect against all this radiation? Filters in the helmet?
Exactly. The welding helmet isn't just a dark piece of glass. It has specific filter shades, defined by international standards like BSEN 169. These shades limit the amount of UV, visible, and IR radiation reaching your eyes. Choosing the right shade number for the type and intensity of welding is critical.
It's not just dark, it's correctly dark.
Precisely. And beyond the helmet filter, you still need things like safety goggles or a face shield for grinding, chipping, basically any time there are flying particles. And we mentioned noise earlier. Ear defenders are often part of the essential PPE kit too.
Okay, so we've covered electric shock, heat, and light. That leaves fumes and gases and noise. Let's talk fumes first. This sounds like another invisible danger.
Very much so. And it's complicated because the makeup of welding fume changes depending on, well, lots of things. The welding rods or wire being used, the metal being welded, any paint or coating on that metal, even contaminants just floating in the air.
So the risks vary quite a bit.
They do. But we can talk about general effects. There are acute effects, things that happen quickly and are usually temporary, like burning eyes or skin, feeling dizzy, nauseous, maybe getting a fever.
I've heard of metal fume fever. Is that common?
It can happen, particularly when welding galvanized steel, which releases zinc fumes. It feels like the flu chills, fever, aches, but it's temporary. Usually clears up in a day or two.
Okay, temporary. But are there long-term effects?
Yes, and those are more worrying. Chronic exposure, meaning day after day for years, can lead to things like siderosis. That's where iron particles build up in the lungs. It might not cause symptoms initially, but it can eventually reduce lung function.
Iron buildup, okay.
But then we get to specific, highly dangerous substances. And the sources really highlight one in particular, cadmium fumes.
Cadmium, where does that come from?
It can be found as a coating on steel, sometimes in plating or in certain types of silver solder. And the danger is extreme. Cadmium fumes are described as highly toxic and potentially fatal, even from very brief exposure.
Fatal. How brief?
The source material is starkly specific here. It says as little as 20 minutes of welding in the presence of cadmium can be fatal. Symptoms might look a bit like metal fume fever initially, but it's far more serious and should never be confused. Symptoms could appear within an hour, and death could follow about 5 days later.
20 minutes. That's terrifying. It really drives home how vital it is to know exactly what you're working with.
Absolutely critical. And just to give you an idea of the toxicity difference, you mentioned occupational exposure limits, or OELs. These are the legal limits for exposure in the workplace, usually averaged over an 8-hour shift, the time-weighted average, or TWA.
Right.
For general iron oxide fume, the limit is around 5 milligrams per cubic meter of air.
Okay.
But for cadmium, the OEL is just 0.05 milligrams per cubic meter.
Wow, that's 100 times lower.
100 times. It just shows the incredible difference in toxicity between substances. You absolutely must know if cadmium or other highly toxic things like beryllium or lead could be present.
Okay, so that covers fumes. What about gases? Are they different?
Yes, distinct hazards. First, you have the shielding gases used in some welding processes. Argon, helium, carbon dioxide. They aren't toxic in themselves, but they can displace the oxygen in the air, especially in closed spaces.
Great.
If the oxygen level drops too low, you can get dizzy, pass out, and if the brain is starved of oxygen for too long, it could be fatal. Simple asphyxiation.
Okay, displacement is the risk there. What else?
Then you can get gases produced by the welding process. Some degreasing solvents used to clean metal, like trichloroethylene or perchloroethylene. If residues are left on the metal, the heat and UV from the arc can break them down into highly toxic gases like phosgene.
Phosgene. That sounds nasty.
It is. Very dangerous. And even the air itself can react. The intense UV radiation can react with oxygen and nitrogen in the air to create ozone and various nitrogen oxides.
And what do?
They can cause headaches, chest pains, irritation in the eyes, nose, and throat. Ozone specifically can cause excess mucus, coughing. Other gases mentioned, like nitrous oxide, hydrogen chloride, they can cause delayed lung irritation, fluid buildup. And carbon monoxide from incomplete combustion reduces oxygen in the blood, causing drowsiness, headaches, nausea, potentially fatal oxygen starvation.
It really is a chemical soup sometimes. So with all these fumes and gases floating around, how do you actually control exposure?
Well, the simplest, most basic rule, often overlooked, is keep your head out of the fume plume. Sounds obvious, right?
Yeah.
But the concentration of hazardous stuff is highest right there, rising from the arc. Just positioning yourself slightly differently can make a big difference.
Okay, position matters. What else?
Beyond that, there's a clear hierarchy for ventilation. First prize is always mechanical ventilation or local exhaust ventilation, LEV, right at the source. A fume extraction gun or a hood positioned close to the arc to suck the plume away immediately.
Get it before it spreads.
Exactly. Yeah. If that's not possible or not enough, then you look at general ventilation for the whole area, maybe fixed fans or movable exhaust hoods to keep the air moving and diluted.
And if that's still not enough?
Then, as a last resort, if you absolutely cannot get the fume and gas levels down sufficiently with ventilation, you have to use respiratory protective equipment, RPE, masks, or breathing apparatus.
So RPE is the final safety net.
It is. And the sources offer a useful rule of thumb. If the air in the workshop looks visibly clear and the welder feels comfortable, doesn't notice any smells or irritation, then the ventilation is probably adequate. But that's just a rough guide, not a substitute for actual measurement if there's a known hazard.
How do you know if there is a known hazard? How do you identify these substances?
Good question. Several ways. First, check the material safety data sheet, the MSDS, for the welding consumables, the rods or wires. That should list hazardous ingredients and the fumes they might produce.
Okay, MSDS first.
Second, know your occupational exposure limits, the OELs, usually found in regulations like COASH in the UK. These tell you the maximum safe concentration for healthy adults.
Like those numbers for iron and cadmium we talked about.
Exactly. Third, you absolutely have to know what the base metal is, and critically, if there are any coatings, paint, galvanizing, plating, because heating those can release toxic fumes or gases. We mentioned cadmium, but things like lead paint are obviously hazardous too. And even some elements in the metal itself, like chromium and stainless steel, can form hazardous compounds like chromium-6, which is considered a carcinogen.
So you need info on consumables, OELs, base metal, and coatings.
Right. And COSH regulations actually require employers to assess the risks, and often that means measuring fume levels both in the general workshop air and right inside the welder's breathing zone, plus regular monitoring and audits to make sure controls are working.
If RPE, the masks, become necessary, are there any downsides? You mentioned it's a last resort.
There are definitely considerations. RPE isn't a simple fix. First, it has to be the right type for the hazard, it has to be approved standard, properly maintained, stored correctly, and crucially, it has to fit the wearer correctly. Fit testing is essential.
So proper management is key.
Absolutely. Selecting it, maintaining it, fit testing, training people how to use it properly, all that requires trained staff. But even when used correctly, RPE can have downsides. It can make communication harder, slow down the work rate, restrict movement, reduce visibility sometimes, interfere with other PPE like helmets or ear defenders, and even make using tools more awkward.
So it's a trade-off. Necessary sometimes, but ventilation is always better if possible.
Definitely preferable. RPE protects the individual wearer. Ventilation removes the hazard from the environment.
Okay. One more thing under fumes and gases. Confined spaces, that seems like a whole extra level of risk.
It really is. A confined space isn't just any small space. It's defined as an enclosed place where there's a foreseeable risk of certain specific dangerous things happening. Think tanks, silos, pits, large pipes, ship hulls.
And what are those specific dangerous things?
Things like fire or explosion, losing consciousness or suffocating because of gas, fumes, vapor, or just a lack of oxygen, drowning, being asphyxiated by a free-flowing solid like grain in a silo, or even losing consciousness because of excessive heat.
So welding inside something like that
Requires extreme caution. You absolutely need a thorough risk assessment, a formal permit-to-work system, and usually pre-entry gas testing, maybe continuous monitoring while the work is ongoing. There's zero room for cutting corners in confined spaces.
Understood. Okay, that covers fumes and gases. The last of the four main hazards was noise.
Right, noise. Often overlooked in welding, but it can be a significant issue. The main risk is permanent hearing damage from prolonged exposure. But loud noise can also increase stress, raise blood pressure, make you tired, nervous, irritable.
Is there a specific noise level to worry about?
Yes, the regulations usually set a threshold. A common one mentioned is 85 decibels, averaged over an 8-hour working day. If the noise exposure exceeds that level, then hearing protection must be worn, and employers usually have to provide annual hearing tests.
Is normal welding that loud?
Generally, no. Most common arc welding processes themselves aren't typically noisy enough to cause problems on their own. But there are a couple of important exceptions mentioned. Plasma arc welding, and especially air carbon arc cutting, sometimes called arc gouging. Those can be extremely loud.
So hearing protection is mandatory for those.
Absolutely essential for plasma and air carbon arc cutting, no question.
What about other noise sources in a welding shop?
That's often where the main noise hazard comes from, the ancillary jobs. Things like chipping slag off welds, grinding metal, hammering. Those can be very noisy. So hearing protection is vital, not just if you're doing those tasks, but also if you're working near someone who is.
Right, bystander risk again?
Exactly. And again, noise exposure is also covered by those CSWIP regulations, showing how it's all part of an integrated health and safety picture.
Okay, so we've broken down the four big hazards: shock, heat light, fumes gases, and noise. With all these different risks, how do companies actually manage it all effectively? Is there a bigger picture strategy?
Yes, absolutely. The best practice highlighted in our sources is implementing comprehensive risk management programs. It's about having a structured approach.
What does that involve?
It's a continuous cycle, really. First, you identify all the potential hazards related to the welding operations. Then you assess the level of risk associated with each hazard, how likely is it to happen, and how severe would the consequences be.
Okay, identify and assess.
Then, based on that assessment, you implement controls to reduce the risk down to an acceptable level. That could be anything from changing the process, improving ventilation, providing PPE, enhancing training.
A whole range of solutions.
Exactly. But it doesn't stop there. It's crucial to then evaluate and review the program regularly. Are the controls actually working? Are they effective? Has anything changed? Are there new hazards? It has to be a living process to make sure it stays effective.
Continuous improvement.
Precisely. And circling back to the start, the visual or welding inspector is very often involved in these risk management duties.
Right.
The assessments, checking controls, contributing to the reviews.
Right. Their role ties into this whole management system.
Definitely.
Okay, that's a great overview of the strategy. To maybe wrap things up and make it really practical, could we quickly run through some key safety checks, like a final do's and don'ts list?
Sure. A quick checklist is always useful. So first, do make sure you're aware of the specific health and safety rules for whatever welding job you're doing. They can vary.
Okay. And assume nothing is safe until checked.
Good way to put it. Do ensure your cables are the right size for the current and spread them out if possible. Don't leave them coiled up tightly as they can overheat.
Right. Do verify your work lead connection. The return lead is clamped securely to the workpiece itself, making good electrical contact.
Do make sure you're properly insulated. Don't sit or lean directly on the workpiece or wet ground while welding. Use dry boards or insulating mats if needed.
Okay. Do check that all your electrical connections, including the main earth ground for the power source, are tight and clean.
Do regularly inspect your electrode holder in the welding cable for damaged, cracked insulation, loose connections, overheating signs. Replace anything dodgy immediately.
And a big don't. Don't operate the welding machine with the covers removed. Those covers are there for protection.
Absolutely. And don't forget to disconnect the main input power before doing any internal checks or servicing on the machine.
Another don't. Don't touch any electrically live parts or the electrode with your bare skin or wet clothing. Seems obvious, but vital.
It is. And related to that, do always insulate yourself from both the workpiece and the ground. Wear dry gloves, proper footwear.
Do weld well away from any flammable materials. Clear the area first.
And do secure gas cylinders properly, upright and chained, so they can't fall over and potentially break a valve, turning them into dangerous projectiles, like rockets.
Oh, okay. Secure cylinders.
And do use flashback arresters on fuel gas and oxygen lines for gas welding or cutting. And protect the floor from sparks and hot metal, maybe with fire-retardant blankets or even just a layer of sand in some situations.
That's a great practical list. Thanks. So we've really taken a deep dive today into arc welding safety. We've gone from the instant danger of electric shock
To those invisible threats like cadmium fumes.
the long-term risks from noise and light radiation.
Yeah, it really shows that even in what seems like a straightforward industrial process, there are just so many layers of crucial safety stuff to think about.
It really does. And understanding these specific, sometimes hidden safety measures in a technical field like welding, it kind of changes how you look at any work environment, doesn't it?
I think so.
It makes you want to look beyond the surface, to really think about the underlying risks and the safety systems in place, even for things that seem, everyday or mundane. It leaves you wondering what other common processes might have similarly complex, really critical safety considerations humming away just beneath the surface that we never even think about.